Greetings and welcome to the webinar, Revit Stairs, Giving It Some Style. Again, my name's Adam Hamilton, Building Industry Manager for CTC. The reason I had come up with this topic for Revit Stairs, is that we have a lot of people who all call us up. I know a lot of personal friends in the industry who, using the Revit Stairs, have learned enough to be dangerous. Also, with the advent of the Stair by Component tool that came around in 2013, even the novice users were given access to build Revit Stairs. But what ends up happening is either a use of all the default elements or a misunderstanding of how a lot of these elements work. And we see a lot of workarounds, and we see a lot of hacks, and we see a lot of users struggling to find how to either accurately represent their stair, or the difficulty of reproducing a similar stair in multiple projects. And so having the ability to modify our stairs to use the different styles and the different tools. We're going to take a look at some of those style components, and then we're going to talk about some of the issues and solutions that we've seen with modifying stairs and stair elements, discussing that even though we do have the Stair by Component tool, that the Stair by Sketch is not gone just yet and is still used quite often, and why. So what we're going to do now is just hop over into Revit. As you see, I have a few things already started. Again, as just an intro little piece, is that we do have the Stair tool, and that the Stair by Component is the default tool now. However, that Stair by Sketch is still there, and we'll discuss it in a little bit. But what I wanted to do is jump into a floor plan here, and I have drawn just a stair. And you'll notice that in the type selector we have a couple different stair styles pre-assembled. The assembled stair, 7 max rise, 11-inch tread. We have the cast in place stair, a monolithic stair. And what do these guys mean, and what do they do? The stair types themselves, this edit type button would go into our stair properties, and everything we're going to be taking a look at is inside here, because you can create new types of stairs. As you saw, that we have the default 7-inch max rise or 11-inch tread. This is just a default style. But that style has all of these rules and all of these construction types and support types underneath it that have quite a bit to be modified, to be tinkered with, to be personalized or stylized. And so taking a look at each one of these settings and knowing what they do and how they do, and being comfortable with developing more elements for these stairs to really give us some style. Now again, as we create and edit stairs, one thing I always tell everyone I discuss things with is always duplicate and always rename. Even if you're creating just a test element, as we're going to be doing. But the important reason here is that a lot of times elements can be transferred from project to project. And stairs is definitely one of those, because if you've created an exit stair, an egress stair, steel pan stair, something that you want to use over and over and over again, you got it all configured, it's nice, this project, it looks great, but now I need to bring it into project B, then project C or D. You want to be able to grab those elements, copy and paste them into the next one. We don't want to overwrite things. We don't want to modify it, because there might be elements in there that are already set up. You may have already created some things, and so you never want to overwrite something and have to wonder what changed. Did something I bring in change? Did something I overwrote changed? And have to double check everything. So always duplicate and create a new type. For what we're doing right now, I'm just going to create a test. Okay, and again, because we have these types, as we create additional, they will be in this list, and that way also you can have elements such as a feature stair, exterior stair types. You can have interior stair types, egress stair types, or stair by types by construction. are other ways we've seen it done. And so having those additional stairs in there to save these settings and have them configured, very important. Okay. Now, with each stair type, we've seen people create stairs and start to manipulate them because you can stretch them and make treads bigger, smaller, or things like that inside the project after it's drawn. But the default calculations here are just defaults. They're a good start point. Now it's important to know that just a little tip and trick, 9 times out of 10, a stair is never going to stay at 3 feet. So usually with anything, I change this to 4 feet, change it to 5 feet. Just helps me each and every time why modify it so many times. But what we're going to really look at is the types. And you'll see here when I click into construction, we have run types and landing types. Down here in supports, we have support types, and we see that by this triple dot button. For each one of these categories I select, there's this triple dot button. And that means these are configurable elements. I'm going to start here with the run type, and you see we have this 2-inch tread, 1-inch nosing, 1/4-inch riser. Good description, right? We're going to hit that triple dot button and go inside it, and you see another type properties dialog box. Now inside here again is another chance to create saved settings, create a type. Because by default, when these stairs come in, by default, the tread material, the riser material, all set to by category. And so being able to set your materials, is this concrete? Because I want it to look like concrete. Is it an aggregate? Is it marble? Is it wood? And having those materials set, that way visualization is correct. That way if you cut a section, you have at least some hatch patterning, you know, the filled regions coming through. And so saving those, that way you can add your materialization. But what I really want to look at is down here when we get to treads and risers. Now notice, first things first, there is this checkbox. You can turn on or off treads and risers. Now the riser button it's a good thing to look at, because if I wanted a stair with no riser, something I can see through, and I've done that here, no riser, able to be see-through. Okay, if I want that to occur, that's that riser checkbox. But why would you have a tread checkbox? I'll be talking about that in a little bit, but there's a lot of things inside Revit that are solved that you can't use the tool to create, that you may need to create on your own afterwards. But that's a good thing to know, that you're able to turn off most of these elements. You can turn off the supports, you can turn off the treads, you can turn off the risers. Okay. You may also, by the way, have a stair. I've talked with some people about this, that they may have a custom riser style, maybe a perforated metal panel, maybe some sort of meshing or grating, and that you can't use the default Revit riser piece because of those situations. And same thing with the treads. Inside Revit, the stair tool, each element, each component of a stair, whether it's the tread, the riser, the supports, each one is a profile that is extruded along a path. For the supports, they're extruded up along the edges and around the landings. For the treads and the risers, they start from side right to side left, or left to right, but they're extruded along the depth of the stairs, the width of the stairs. And so any sort of modifications to those pieces can't be done utilizing the stair tool. Sometimes they're utilized with in-place families or wall elements with modified profiles. In this particular, in that case I was just talking about, it could be with a riser family with perforations, and so being able to turn it on or turn it off gives us the ability to manipulate those things as well. But when we look at our tread tool and the tread portion of this, we have the thicknesses, we have the profiles and nosings. Now if you notice, we have two categories here, nosing profile and tread profile. Now these profiles are important, and if you haven't manipulated profiles before, Revit has default loaded in profiles, or editing or in creating profiles yourself um, is a good skill to have if you're modifying stairs. Now the profiles inside your project browser, all the way at the bottom we have this families drop down. Inside the families drop down we can go down to profiles, and we drop this down and you'll see an entire list of profile families. Okay. Now inside here you'll see stair specific naming, and again these two are default. I had created this tread 1 on my own. But creating a new profile is as simple as coming up to your big blue R, creating a new family, and inside the family templates we have profiles. Okay. Now you can use the standard profile template, and the standard profile will give you a crosshair, but it's hit or miss which way you draw it. What I really like to do is start with the stair nosing because it kind of gives a little direction. So whether you're creating a tread, whether you're creating a nosing, I like to start with this particular profile because it gives you these little notes where to draw. Draw profile in this quadrant if you're doing a stair nosing. Here's our riser face, here's our tread surface. So what this is meant to represent is as our stair comes up, this is how we're looking, and it kind of gives you that. So the tread surface, the riser face. When it says draw profile, again, that was in regards to the nosing profile, because if we wanted to add a nosing out here, this is how we do it. The insertion point is very important because when we go back to our Revit stair, and I believe I have a stair section here, and I'll slide that in there. The nosing starts at the beginning of the tread. If I jump in here, take a look at this run style, okay? And if I was to set this back to defaults, default, 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 the riser as default, and apply, okay? The nosing length, if I set this to 0, is in this location. Okay, so adding any type of profile to it will extend it out or shift this back, but that's how it adds it to it. So when we're looking at those crosshairs are located right here. Okay. Now creating a family, we have family classes. Otherwise, we have other webinars that have gone over some of this information, so generating that is not a problem. It's just knowing that if you are modifying a default loaded profile, or if you're looking at creating your own, knowing where this point is, the insertion point, or knowing which way the tread surface and the riser face are when creating your piece. Now, the nosing profile, again, this could get added to the front of your stair. It can be as simple as a shape, and this is actually very representative of what some of the default loaded in nosing profiles look like. Okay. It could be a bull-nosed nosing, but just know again where it is you're drawing from. And you create the closed polyline because again, this is going to be stretched over it. Okay, and it just gets added to the front of that stair. Now, one thing is if you were creating a tread, if you have a custom shape, and if you noticed mine here, I created this tread profile, and it was based off of a particular manufacturer had a specific tread shape. And it was a pan shape that was going to be infilled with concrete, and so I created that shape. This is a custom family I built, just as an example, because we have the tread surface, riser face, and so you can create any shape you'd like, depending on how you want this to look. So if there's supports, you can create any shape loaded in, and just use good family building good family building techniques when doing this. Use some reference planes, use some parameters to control this. Now, one thing to note is any parameters you do create. So if you were to create some parameterization inside here, any parameters you do create, whether it's depth, width, height, all of these should be created as type-based parameters, not instance. A lot of times people create instance parameters and wonder why they can't utilize them back in the project. So once these things are loaded back in, and I'm just going to close out of this here. Okay. Once those profiles are loaded back in and they're part of your list, and here he is, whether it's the custom one that you loaded in or if you're attempting to modify one of the default styles, okay, these styles can be edited by double-clicking, and you have the ability to edit those. If you have a parameter, in which case mine does, I have this tread depth. Again, this is a type-based parameter, and so I can modify the shape and size of those parameters inside my project and create, again, additional types. So I can create an 11-inch, or maybe if I want a 10-inch. Okay, and again, these are pertaining just to the size, because any materialization or anything like that happens inside the stair style. And so I can create this 10-inch type. And now I can choose that 10-inch type. And if I hit okie dokie, I can choose that 10-inch type from my stair type editor. And now I have my tread 1 10-inch, and I can swap that out. Shortens it up. Okay, so editing types, the parameters need to be type-based parameters, not instance-based parameters, because you wouldn't be able to edit those. And even though they're gray, a lot of times people select them, and they're like, oh, this is gray, how do I enter it? It's just a matter of double-clicking, and then you get the editor that you can create additional types from. Or select and edit the family, select the top of the tree of the family, edit, and that will take you into it. And again, you can add elements to it. And I bring that up because there are some default families already in here. Okay, so whether it's the stair nosing pan or stair tread family already there, you can edit the default families. And again, I always recommend save as before reloading them back in, so you can add parameters to them that can then be edited back inside the project. So editing the default families or creating a new parameter yourself is a good skill to learn. Now, one thing, whether you're creating a tread, creating a nosing, okay, the way profiles are read, because as you saw there's quite a bit of profile templates. I believe there's a good 5 or 6 of them here. Okay, the way they only show up in one dialog box or another is based on this profile usage parameter, and it's always good to make sure that that is set. And you can set it to stair nosing, stair riser, stair support, or stair tread. And that's how we have access to them. Okay. Now those tread pieces again have parameters already included for thickness, so it'll grow, or nosing length. And again, those are important too, because if your profile does not match the tread thickness, you may have drawn your nosing at 1.5 inches or at 2 inches. But if your tread thickness shrinks or thickens, so if you happen to be using a 2x4 and that's 1.5 inches thickness, but your nosing that you have chosen is only an inch. It does not automatically size itself, so you'll need to make sure that you do have the proper parameterization to add that nosing. Otherwise, it's just going to add a little nub off the edge. So it just letting you know it does not match automatically tread thickness. Okay. Now, same thing with risers. Risers have profiles too. So if you did happen to choose a profile, there are riser profiles as well. And I bring this up because you know, some of the people who call up are doing, say, residential stairs or something like that. And the default is this, you know, 1/4 inch thick plate. And so you would need to create either a new style under default with the proper thickness, or you utilize this thickness here to be, say, 1.5 inches, or if you're using any other size or shape to be able to load that in. Now, I've looked at a couple manufacturer websites regarding stair pans. So if you search up steel pans, there's quite a few. Just know that there is a lot of those elements, if you try to duplicate them off the manufacturer's site or something like that, kind of combine nosing, tread, and riser elements, and so you may have to break up those profiles into a riser profile and a tread profile and a nosing profile. So just know that you may need to kind of think through. I always say think of what you're trying to accomplish, and then sometimes you need to work backwards from there. Okay? So we have those as well. Okay, and the ability to extend behind or under or just join them all. Okay, so creating these types, very important, and again, also the materialization. Again, these can be saved and transferred project to project, or you know, you copy your whole stair. They'll come with it as well, as long as they're in use. Okay. Landings have very similar types as well. Most of the time it's left as same as run, unless you're utilizing, say, a custom landing and you want different materialization or different structure around it. Utilize the same as run function, but if you uncheck that, you do have access to this additional tread material. You can create a different landing, and that might be if you have a carpet landing, or if you have a different, you know, a fancier material. Maybe you got some nice stonework or tile work on your landing where you're doing a concrete stair. Having that different material is good too. Or if you're utilizing a different thickness. So again, if you were doing a tile and that tile happens to be, you know, a 5/8 inch thick tile, where you're using, you know, concrete and a bed mortar or something in your stair, you can modify this and have a different settings, whether it's the thickness, whether it's the material, and even a different profile. Okay. One last thing I wanted to talk about, I forgot I skipped over this when I was doing this because it was grayed out. But if you do choose a nosing and you have a particular profile, you do have the ability to apply the nosing to different sides of your stair. So if you do have, say, an exposed edge, whether that's because you have your supports are underneath the stair, or if you have you know, they're mounted to one side of the wall or not, and you have an exposed edge, you have the ability to wrap the nosing profile around not just the front, but front and left, front and right, or front, left, and right. If you do want this profile to extend to the back, then it's recommended that you just make that part of your tread profile and disregard any nosing at all. Okay, just good to know. The next thing I wanted to look at were support elements. And support elements are important because we've had a lot of conversations thinking that the Revit stairs are always based on this you know, very commercial style where the stringers are mounted to the outside of the stair, and how do I tuck them underneath? Or even then, you know, I have custom supports or you know, skeletonized supports, or even multiple supports underneath, not just a left and right. And so just the default stringer closed mounts to the side, open tucks them underneath this carriage open, okay, or none at all, and that's the ability to turn them off. Now, turning them off could be something where you might be using an in-place family for something like that, or a loaded family where you want to have control of that. And again, some of the reasons that would be is I've seen stringers that have are skeletonized, and so you want to have, say, a piece of metal, and I'm just going to draw this in with some line work. Where I've seen this before as I was looking around for different stair styles, where elements came through, and so there was a skeletonized piece of steel, and you could see through it. And then it returned to a standard thickness stringer all the way back. Now Revit doesn't have the ability to cut the profile of a support in this direction. Okay, treads and risers and nosings run the width of the stair, but when we talk about how the structure, the supports are run, they run perpendicular from bottom to top, and so they're extruded along the length of the stair, say this path, this direction, and so you can't cut that way. Okay, and so some of the more custom styles, a lot of times either you put it in like so, or you will hide them and then add in your own pieces yourself after your stair has been kind of masked. So it's good to use the Revit tool. A lot of times the Revit tool can be used as a placeholder until a final design is created, and then you can either hide or turn off or set to none. Okay. But what we have inside the stair type for supports, again, whether you're tucking them around, but they do have types. I'm going to go in there because, again, we have materials. Those materials, especially if it's painted, you might need to be duplicating some materials and calling something like, say, steel painted, a color. Or polished, but the profile we use, the section profile, by default we've always been using this 2-inch wide by 1 foot depth profile, and it's amazing how many buildings I've looked at and opened up, and that's what I see, and I'm just kind of like, I know that's not how they're building it. So whether they're using tube steel or whether they're using C channels or whether it's wood or not, the modifying and saving new types for your stringers. If you're using the default rectangle, and there it is, the default rectangle, or you have the ability to load the C channel, which is loaded in by default, but again, the default size that you only have access to is a C9 by 15. Okay, so you have the ability to go out to the families, and just like the profiles we saw before, you'll see this C channel profile, and there's only the C9 by 15. Okay, and again, double click, you can duplicate and create a new size. Okay. Or we're going to hop back in here and use the default rectangle, and you can change it to whatever size you would like. The size is typically good. A lot of people do use it, but the structural depth on run is the biggest one that we look at, and that's just the ability, and cannot be a negative number. So whether you're going from 0 and it lines it up, okay, or start to increase the size, 6-inch, apply, and you see it start to shift back farther and farther and farther back. Okay, and default 2.5-inch gets it right back there. So the structural depth on run. Now, most of the time with these stringers, a lot of times the the carriage, when tucking underneath a stair, it lines itself up with the outer edge. Okay. When you do choose an open style, this carriage open style, you do have the ability to establish an offset. So offset from the edge, and that can bring it in. However, it's a uniform, this is only affecting the left side of the right side. You also have this middle support. So if you did tuck any elements under and want a middle support, or I've seen this happen a few times where you say, no, I don't want any, but I do want a middle support, and then you get something fun like this. Okay, and that can be increased to be some sort of rough sawn timber, or something, a glulam beam or something like that, where I've seen that before. I've done that personally. But when you start to add supports to it, and just set this over here, you can increase the amount of center supports. But when you do this, there is a limitation that you do not get to control the spacing. It just starts to do its own centering, equal space, and so there's no real control over that. But you can have as many as you'd like equally spaced underneath. And again, that's usually where some people will start to come back and modify or turn off the supports and create their own custom. So we have the ability to throw in these middle supports, and with that middle support, again, it's a type-based as well. Okay, so being able to create your own custom type for that specific one is very useful. That way, you can have different support style for each one of these supports: the left, the right, or the center. Okay. Now, this happens to be the component-based stair. This is a component stair, and if I select it, you can see that we have this component options. I had drawn this as a component stair. Now, some of the limitations when customizing stairs is these elements. It's good to know. Yes, cancel. It's good to know that when modifying stairs, you do have that option to tinker with the stair. It doesn't have to be a perfect rectangle. It can be modified shapes, and you see that I have this guy down here. I have even some funkiness happening down here. So whether you're flaring out a stair or modifying, you can select a component and edit the sketch. So you can convert it and edit sketch. And from the edit sketch, you have the ability to modify it from here and have that represent back. That's the sketch mode. Now, there is a fundamental thing, though, that the converted component, so if you create a component and convert it to a sketch, it still is semi-limited to the constraints of a stair by component. Okay, and what that means is certain elements can't be extended. There was a workaround where if you want to extend a support farther. So if I undid this little minor change, extend a support, because by default the support, as you see here, stops at the edge of the tread, okay, that you could pull this line past and it would extend it out. But with the stair by component, even though you've made those modifications, it does not do it. So there are times when a stair by sketch is still important. Okay, if I was to then create using the same idea, and I go to architecture and I use the stair by sketch tool, and just a standard run. Okay, I hit okie dokie. Pull this guy down here. Okay, again, by default the support stops at the edge of the stair. However, if I edit the sketch of the stair and pull this support out to say match up with, or to line up with, say, a trim board or something like that, or I just want it to extend out, when I accept that, it does extend out, and if I jump to section, now you see it has extended past. okay? And so we have that ability, that function is just not available in the stair by component tool. You need to have created a stair by sketch. Okay. Also, it's important to know that whether stair by sketch or even if you convert, if you wanted to do, say, a half-size tread or an extension like that, you can. You just have to modify this tread, and now you can create a partial depth tread. And again, that's always good if you're lining up with, a slab up top or something like that. Need at least a partial tread. Some of those tools also lend us to one more thing, and it's usually a hard thing to find, is when you want to start or end with a riser. And when you're in sketch mode, it's no big deal because you can just select the sketch, and in the type we have begin with riser or end with riser. And here you'll see end with riser because you'll be able to see it over here. To end with a riser, and you hit apply, it redoes the math for you. Okay, so you will need to modify. Your sketch, but you're able to add that additional tread up. And now you can end with the tread versus ending with a riser. And again, you can modify that. It's a hard thing to find, or if you're not looking very hard, on a component stair, when you edit a stair, you have to select the component to be able to get access to the begin with riser or end with riser. Okay? And you also have this extend below riser base in case you wanted to extend, say, the structure or the if you're using concrete or something like that in a monolithic stair, you can extend that below the floor level. Edit the stair, grab my component, and you can extend below 2-inch, and extends below or raises up. So you can do minus, you can do plus, and it will either raise it up or bring it down below the start or end point. So if you're using anything like that, maybe there might be a base plate down here that you need to start half an inch up, or maybe you want this structure to extend farther down to tie in with an edge of slab. You can extend that down a certain length. However, if you do extend it down, it will never exceed the face of the tread. So in case you do modify that and say 1 foot, it will always stop in line with the tread no matter how far you tell it to extend. Okay, so some of these style type properties, some of the styles that we're looking at, these are good things to know. They're little tricks and hints that a lot of people don't know unless you start clicking around and grabbing around. Now there's a couple other things that I wanted to hit on before we end today, and that's when we're modifying stairs. Now usually I've told a lot of people that there's a lot of stuff that you can do to stairs, and believe me when I say stairs can be very difficult. Okay, and a lot of times in a lot of firms there's a stair guy or a couple stair guys, and it's only because you get good at it by screwing it up as many times as possible. Okay, that's really the only way to get good at building stairs, because a lot of times a stair will fail for really no reason, and it's all a matter of the right clicks in order to get everything to work right. And so here I'm going to edit the sketch. And we have a jog. For this particular one, the boundary line, you must have one continuous boundary. And so for me to get this jogged stair, okay, I had to have a continuous boundary. And it's the only way for that to work. If I extended the black line over, and this is the riser line, you would get an error that's not continuous. You can no more than 2 boundaries, and that can be a chain, but it has to be one singular chain, and this creates that gap. And so creating those green lines, boundary, Okay. Now, one thing to caution with is if you do anything like this, a nosing will notch out because a stair by sketch is an extrusion. And so when we look at that, and it's this guy over here, okay, when we look at that, if we have any type of nosing, it will notch out the tread beneath it. So if I come down here, if you notice I have no nosing, it's set at 0, but if I was to add that nosing back, say an inch, and apply okie dokie, and accept that sketch, notice it notches it out. Okay, so be careful when doing that. If you're doing something custom like this, you may need to plan ahead. It's one of those little tinkers that you have to find and modify. Okay, the other thing, I'm going to undo that so it doesn't get all weird. Okay, the other time is when you might want to wrap. You want to wrap a tread around. Now, the trick with wrapping a tread, I'm going to start by sketch here. Okay. The trick with wrapping a tread is that typically you can only get away with wrapping this first tread, and it might give you an error. Okay. And usually I can do this by boundary. Bring this line back, not boundary line, but riser line. And I can pull back this green line, and I can get a wrapped tread. And whether it's a circular or whether it's round, but I have noticed in 2015 that it does sometimes cause issues with supports when you're tinkering with that. I've had it work, I've had it not work. Again, this is one of those things where you just got to tinker with it. So you may need to turn it on or off. But you typically can only get away with wrapping the first tread. If you try to wrap more than one tread, it usually gives you an error because these boundary lines need to be continuous. And so if we were to do this, and then if we were to try to do that with the second tread, in the same manner, riser line, it does not like it. Typically, you can only get away with the first tread being wrapped. If that's something you want to do, now all of a sudden you have to think about maybe making tread families and modifying those independently.